Now, in this lecture, we find out the radius of a circle. In the drawing, we have triangle ABC. Triangle ABC is the right triangle. Inside this right triangle, we have this circle, and our mission is to find out the radius of this circle. In addition, we know that angle ABC is a right angle. It is equal to 90 degrees in its size. This is line segment AS, which is equal to 1 unit in its length. This is line segment ST, that is equal to 3 units in its length. And this is line segment TC, that is equal to 2 times square units in its length, according to what is given as the question. Again, our mission is to find out the radius of this circle. So, first of all, we'll define the center of this circle, this point as O. We'll define the radius of this circle, that is the radius that you are looking for in this question. So we define the radius of this circle as x. So our mission is to find out the value of x. So the radius of this circle is equal to x according to our definition. In the next step, we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O and ends point starts from point O, that is the center of the circle, and ends at point Q, that is a point on the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, that is equal to x according to our definition. You can implement rule 1. And think quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So in the drawing, we have a circle, and we have here tangent AB. It is tangent to this circle. Here it is point M. And we have also the radius OM that is equal to R. So the radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. According to this rule, rule 1. So I can actually implement rule 1 in our drawing. Why? Because in our drawing, we have the radius OQ, that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. Point P is the point of tendency of tangent AB with this circle. So we join points O and P by a straight line. OP, line segment OP is the radius of this circle that is equal to x. And again, we have here the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to the same rule, rule 1. So inside quadrilateral OPBQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees. Therefore, the missing angle here, the missing fourth angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles inside this quadrant, there are POQB to 360 degrees. The missing angle here must be equal to 90 degrees in its size. So inside this quadrilateral POQB, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral POQB as a rectangle. And we also note that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to X, therefore PB must be also equal to X because they are equal to each other. Likewise, according to the sum rule in the same triangle POQB, side PO must be equal to the opposite side PQ. But PO equals to X, therefore PQ must be also equal to X because they are equal to each other. So I shall find out that quadrilateral POQB is not a rectangle but a square. In the next step, we will define the length of this line segment AP as A. And we define the length of this line segment QC as B. Here we can implement rule 10. I will repeat quickly on rule 10. According to rule 10, rule 10 is true in any circle. So in any circle, if we have this circle and we have the common external point P. And for the common external point P, we draw tangent PT for this circle. And we also have here chord AB, the extended chord BA, such as the external point B. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. I remind you that T is the point of tendency of tangent PT with this circle. Again, PT square equals to PA times PB. We actually can implement rule 10 in our drawing. Well, because in our drawing, if you focus on the common standpoint, point A, this is the common standpoint, point A, and from this common standpoint, point A, we have tangent AP that is tangent to this circle here at point P. And we also have chord TS, that's the extended chord TS touches the external point A. So all the requirements of rule 10 are met, or all the requirements of rule 10 are satisfied. Therefore, we can implement here rule 10. According to rule 10, AP square will be equal to AS times AT. Repeat again, AP square will be equal to AS times AT. Repeat again, AP square equals to AS times AT according to rule 10. So AP equals to A, therefore AP square equals to A square. And it must be equal to AS. AS is 1 times AT. From the drawing it is very easy to see that AT equals in total to 1 plus 3. So we actually found out that according to rule 10, a square equals to 1 times 1 plus 3. That is to say, a square equals to 1 and 1 plus 3 is 4. So a square equals to 1 times 4, that is 4. A square equals to 4. Here we take a root of this equation and finally we get that a equals to 2 units in its length. Here, my segment AP is equal to a according to our definition, is equals to 2 units in its length. In the next step, we'll implement rule 10 and the common standpoint point C. So from the common standpoint point C, we have tangent CQ that is tangent to this circle here at point Q, and we also have chord ST, and the extended chord ST touches the external point C. So all the requirements of rule 10 are met, or all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. So we can implement rule 10 in the common external point C. According to rule 10, CQ square equals to CT times CS. Again, according to rule 10, if you focus on the common standpoint point C, CQ square must be equal to CT times CS. CQ equals to B according to our definition, therefore CQ square is B square. And it must be equal to CT. CT is 2 times root of 3, according to what is given as the question, times CS. From the domain, it is very easy to see that this line segment CS, in total it is equals to 3 plus 2 times root of 3. So in conclusion, I shall find out that according to rule 10, B square equals to 2 times root of 3 times 3 plus 2 times root of 3. We will open the brackets on this side of the equation, and finally we get that B square equals to 2 times 3 times 2 times 3 2 times square root of 3 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 is 12. Why? Because 2 times 2 is 4, and square root of 3 times square root of 3 is 3, and 4 times 3 is 12. So in total, 2 times 3 times 2 times square root of 3 times 2 times square root of 3 equals to 12. So in conclusion, we actually found out that b squared equals to 2 times 3 times square root of 3 plus 12. So b squared equals to, here we substitute 12 by 9 plus 3 plus 2 times 3 times square root of 3. So here, this expression 9 plus 3 plus 2 times 3 times square root of 3 is very similar to the algebraic identity that states that a squared plus b squared plus 2 times a times b equals to a plus b squared. If we just substitute a by 3, and b by square root of 3, the value of a squared plus b squared plus 2 times ab will be equal exactly to 9 plus 3 plus 2 times 3 times square root of 3. And we know that a squared plus b squared plus 2 times ab equals to a plus b squared. So this expression also equals to a plus b squared according to this algebraic identity. But what is a plus b squared in relation to this expression? A plus b squared equals to a is 3 plus b is square root of 3 squared. So according to this algebraic identity, 9 plus 3 plus 2 times 3 times square root of 3 equals to 3 plus square root of 3 squared. So those two expressions are equal to each other, and we know that this expression equals to b squared, therefore this expression must be also equal to b squared. So in conclusion, we actually found out that b squared equals to 3 plus square root of 3 squared. Here we take a root out of this equation, and finally we will get that b squared equals to 3 plus square root of 3 squared. Square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732. So b equals to 4.732. So I write it down in the original domain. Here, b equals to 4.732 units. In the next step, we will implement the Pythagoras theorem on this big triangle, the triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right triangle, right big triangle ABC is AC, therefore the square of the hypotenuse is AC squared, and AC squared must be equal to AB squared plus BC squared. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So, what is the length of AC? The length of the hypotenuse AC from the drawings is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So in total, AC equals to 4 plus 2 times square root of 3. And therefore AC squared will be equal to plus 2 times root of 3 squared, and it is equals to AB squared. From the drawing, it is very easy to see that AB equals to x plus 2. AB equals to x plus 2, therefore AB squared equals to x plus 2 squared. Plus BC squared. BC, here it is very easy to see that BC in total equals to x plus 4.732, therefore BC squared will be equal to x plus 4.732 squared. In conclusion, we found out that 4 plus 2 times root of 3 squared equals to x plus 2 squared plus x plus 4.732 squared. So here 4 plus 2 times root of 3 squared, in total it is equals to 55.7128, and it must be equal to x plus 2 squared. X plus 2 squared equals to x squared plus 2 squared, that is 4, plus 2 times x times 2 is 4x, plus x plus 4.732 squared, x plus 4.732 squared equals to x squared plus 4.732 squared, that is actually equals to 22.3918, plus 2 times x times 4.732, that is equals to 9.464x. So in this side of the equation we have 55.7128. In the other side of the equation we have here x squared plus x squared is 2x squared. Here also here 4 plus 4x plus 9.464x equals to 13.464x, and 4 plus 22.3918 equals to 26.3918. Here we will subtract 55.7128 from this equation. So in this side of the equation we left with nothing, 0. On the other side of the equation we have 2x squared plus 13.464x, and we have here 26.3918 minus 55.7128, that is equals to minus 29.321. In conclusion, we found out that 2 times x squared plus 13.646x minus 29.321 equals to 0. Here we divide this equation by 2, and finally we will get 2x squared over 2 is x squared plus 13.464x over 2 is 6.732x, and minus 29.321 over 2 is equals to 13 minus again minus 29.321 over 2 is equals to 14.66 minus 14.66. In conclusion, we actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we just put the values of a, b, and c in our specific quadratic equation, this specific quadratic equation, inside this general formula for x, in order to find out the value of x for our specific quadratic equation. So we do it now, and we will get that x equals to minus b. b equals to 6.732, therefore minus b is minus 6.732 plus minus the square root of b squared. b equals to 6.732, therefore b squared is 6.732 squared, that is actually equals to 45.3198 minus 4 times AC. So minus 4 times A is 1, so minus 4 times A is minus 4 times 1, that is minus 4, times C. C is minus 14.66, so minus 4 times minus 14.66 equals to plus 58.64, all divided by 2a. A is 1, so 2 times a is 2 times 1, that is 2. In conclusion, we actually found out that x equals to minus 6.732 plus minus the square root of 45.3198 plus 58 10.64 equals in total to 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.9598 is equals to 10.196 all divided by 2. So clearly here we will have two solutions that are possible for x. One of those solutions will be a negative solution, because the negative solution is x equals to minus 6.732 minus 10.196. That is definitely a negative number. And because of the fact that according to our definition x is the radius of this circle, a radius is a length, so x as a length must be a positive number. Therefore, the negative solution is incorrect solution. We will cancel the negative solution, and we left only with the positive solution that is possible for x. According to the positive solution, x will be equal to minus 6.732 plus 10.196 divided by 2. So minus 6.732 plus 10.196 equals to 3.464 divided by 2. And 3.464 divided by 2 is equals to 1.732. So we actually found out that the radius of the circle, the radius that we are looking for, is equal to x, it is equals to 1.732 units. And that is the answer to the question. I repeat again. The radius x of this circle equals to 1.732 units. In the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle. So, in the drawing, we have a right triangle ABC. This is again ABC, this is right angle. Line segment AS equals to 1 unit in its length. Line segment ST equals to 3 units in its length. This is line segment TC, this is equals to 2 times square root of 3 units in its length. Inside this right angle ABC we have this circle. And our mission is to find out the radius of this circle. So, first of all, we defined the center of this circle, this point as O, and we define the radius of this circle, the radius that is the radius that we are looking for in this question. We define the radius of this circle as x. In the next step, we join points O and Q together by a straight line. So, what is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and then at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle that is equal to x according to our definition. We implemented here rule 1. Because of the fact that we have the radius OQ that is drawn to point Q, therefore, according to rule 1, whenever you have a radius that is drawn to the point of tendency, the point of tendency is Q, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x according to our definition. Here we can implement rule 1. Why? Because we have the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So inside this quadrilateral PBQO, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing fourth angle must be equal to 90 degrees. In order to complete the sum of the angles inside this quadrilateral POBQ to 360 degrees, the missing angle must be equal to 90 degrees in its size. So inside this quadrilateral POQB, we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to this quadrilateral POBQ as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in quadrilateral POBQ, side PO must be equal to the opposite side BQ, but PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the third rule, in rectangle POQB, side OQ must be equal to the opposite side PB, but OQ is x, therefore PB must be also equal to x. So actually found out that quadrilateral POQB is not a rectangle but a square. In the next step, we define this line segment AP as A, and define this line segment QC as B. Here we implemented rule 10, repeat quickly rule 10. According to rule 10 is true in any circle. So we have this circle and we have the common standpoint point P. From the common standpoint point P, we have tangent PT that is tangent to the circle here at point T. And we have also here chord BA. The extended chord BA touches the common standpoint point P. So all the requirements of rule 10, actually this is rule 10. So in this drawing, the following equation will be true, that PT square must be equal to PA times PB, and PT square equals to PA times PB. We actually can implement rule 10 in our drawing. Why? Because in our drawing, if you focus on this common standpoint point A, from the common standpoint point A, we have tangent AP, that is tangent to this here at point P. And we have also the extended chord TS touches the common standpoint point A. So therefore all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, AP square must be equal to AS times AT. Again, AP square equals to AS times AT. Repeat again, AP square equals to AS times AT according to rule 10. AP is A, therefore AP square is A square. AS is 1, AT is 1 plus 3. So A square equals to 1 times 1 plus 3, that is 4. So A square equals to 1 times 4, that is 4. A square equals to 4. We took a root from this equation and finally found out that A equals to the square root of 4, that is 2. Here A equals to 2. In the next step, we implemented rule 10 in the common standpoint point C. From the common standpoint point C, we have tangent CQ that is tangent to this circle here at point Q. We also have chord ST, in the extended chord ST such as the common standpoint C. Therefore, all the requirements of rule 10 are satisfied. For that reason, we can implement rule 10. According to rule 10, CQ square equals to CT times CS. Again, CQ square equals to CT times CS. Repeat again, if we focus on the constant point C, according to rule 10, CQ square equals to CT times CS. CQ is B, therefore CQ square is B square, and it is equals to CT, it is 2 times square root of 3. CS is 3 plus 2 times square root of 3. We open the brackets on this side of the equation and found out actually that B square equals to 2 times 3 times square root of 3, and 2 times square root of 3 times 2 times square root of 3 is 12. Here we substitute 12 by 9 plus 3, and we actually found out that B square equals to 9 plus 3 plus 2 times 3 times square root of 3. So here, this expression 9 plus 3 plus 2 times 3 times square root of 3 is actually equivalent to the expression a square plus b square plus 2 times ab if we just substitute a by 3 and b by square root of 3. We get that this expression a square plus b square plus 2 times ab will be equal exactly to 9 plus 3 plus 2 times 3 times square root of 3. And because of the fact that according to this algebraic identity, this expression equals to a plus b square, it means that this expression must be also equal to a plus b square, when a equals to 3 and b equals to square root of 3. So in total, according to this algebraic identity, this expression equals to a is 3 and b is square root of 3 square. So it is 3 plus square root of 3 square. And because of the fact that this expression equals to b square, and those two expressions are equal to each other, therefore this expression must be also equal to b square. So in conclusion, we actually found out that b square equals to 3 plus square root of 3 square. Here we took a root out of this equation, and finally found out that b equals to 3 plus square root of 3, and square root of 3 is 1.732, therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, actually found out that b equals to 4.732. Here b equals to 4.732. In the next step, we implemented the Pythagoras theorem on the right big triangle, triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Repeat again. According to the Pythagoras theorem in the right big triangle ABC, AC square equals to AB square plus BC square. AC is 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square, and it is equal to AB square. AB is x plus 2, therefore AB square is x, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is 4.732 square. So in conclusion, I actually found out that b plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. 4 plus 2 times square root of 3 4 plus 2 times square root of 3 square equals to 55.7128, and it is equals to x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732, x plus 4.732 square equals to x square plus 4.732 square, that is equals to 22.3918, plus 2 times x times 4.732, that is equals to 9.464x. So in this side of the equation we have 55.7128. In the other side of the equation we have x squared plus x squared, that is 2x squared, and we have also 4x plus 9.464x, that is 13.464x, and we have also here 4 plus 22.3918 equals to 26.3918. Here we subtracted 55.7128 from this equation, so in this side of the equation we left with nothing, 0. In the other side of the equation we left with 2x squared, and here we have so we have, in the other side of the equation, we have 2x squared plus 14.464x, and we have here 26.3918 minus 55.3128 equals to minus 29.321. So here we divided this equation by 2 and found out actually that 2x squared over 2 is x squared. 14.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66. In conclusion, we actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we found out the value of x. We will find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say x squared plus 6.732x minus 14.66 equals to 0, the coefficient a equals to 1, the coefficient b equals to 6.732, and the coefficient c equals to minus 14.66. So we just have to put the data, the values of a, b, and c from our specific quadratic equation in this general formula for x in order to find out the value or the values of x from our specific quadratic equation. And the general formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we put the values of a, b, and c in this general formula for x in order to find out the value of x. So we did it, and we actually found out that x equals to minus b, b equals to 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. b equals to 6.732, therefore b squared equals to 45.3198 minus 4 times ac. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4 times c is minus 14.66, so minus 4 times minus 14.66 equals to plus 58.64, all divided by 2a. A is 1, so 2a is 2 times 1, that is 2. In conclusion, I actually found out that x equals to minus 6.732 plus minus square root of 45.3198 plus 58.64 over 2. So 45.3198 plus 58.64 equals to 103.9598. So in conclusion, I actually found out that x equals to minus 6.732 plus minus the square root of 103.9398. So x equals to minus 6.732 plus minus and the square root of 103.9598 equals to 10.196 divided by 2. So here we have two solutions that are possible for x. One of the solutions are negative solution, and because of the fact that x is the radius of this circle, and a radius must be a positive number, a radius is a length, and the length must be a positive number, therefore the negative solution is incorrect, so we cancel the negative solution, and we relate only to the positive solution. And the positive solution for x is that x equals to minus 6.732 plus 10.196 over 2, and minus 0.672 plus 10.196 equals to 3.464 divided by 2, and 4.464 over 2 is 1.732. In conclusion, I actually found out that the radius of this circle, the radius x, equals to 1.732 units. Okay, thank you very much.